In this video, I am going to explain some of the important questions on applications of trigonometry from the point of view of 24-25 board exams. Please like, share and subscribe to my channel. Some applications of trigonometry. What are the applications of trigonometry? To measure height and distances. There are some technical terms in order to understand the applications. What are they? For example, this is a building. We can measure the height of the building. Okay, this is the observer. Look at the figure. This is horizontal line which connects the objects and the eye of the observer. This is horizontal line. Now, this is a line of sight. What is line of sight? Line of sight is the line drawn from the eye of the observer to the point. Now this is the point in the object viewed by the observer. Now this angle is angle of elevation. What is angle of elevation? Angle of elevation of an object. Look at the figure. This is the object viewed. Is the angle formed by the line of sight, this line of sight, with the horizontal line. When it is above the horizontal level, here observe, this line of sight is above the horizontal level. Then this is what? Angle of elevation. Now this is the building, when the observer is on the building, observe the figure, then this is the horizontal line which is drawn from his eyes, and he is observing a car which is below the horizontal line. In order to look at the car, he has to lower his head. This is the line of sight. You know what is the line of sight. Now this is angle of depression. Look at the figure. So what is angle of depression? When an object is viewed, it is the angle formed by the line of sight. This is line of sight with the horizontal line. That is the case when we lower our head to look at the object. Now let us solve some of the questions which appear in the example, which may be simple or difficult. All of them carry 4 marks. From the top of the vertical building of 50√3 meter height on a level ground, angle of depression of an object on the same ground is observed to be 60 degree. Find the distance of the object from the foot of the building. Now what they have given? A level ground. So let AB be the level ground. On the level ground, a building is there. Okay. Let AC be the building. Its height is 50√3 meter. Now angle of depression of an object, let B be the object, on the same ground is observed to be 60 degree. So now let us have a horizontal line CD and the line of sight BC. This is the ground object. This is, observe the figure, C is the observer. So this angle DCB is 60 degree. So angle of depression, it is given 60 degree. So angle DCB is 60 degree. Since CD and AB are parallel lines, Now we can have angle CBA. This angle what? 60 degree, because alternate angles are equal. Now we have to find the distance of the object from the foot of the building. So distance of this is the foot of the building. A is the foot of the building. B is the object. So now we have to find AB. Now let us have only the triangle ABC. Here we have to find AB. So in right angle triangle ABC, tan 60, because TOA is opposite and adjacent. We are dealing with only these two sides. So tan 60, opposite by adjacent. Here opposite is AC, adjacent is AB. Tan 60 is root 3 as we know it, isn't it? AC it is given 50 root 3 meter. AB we have to find out. Here root 3 and root 3 get cancelled. So AB is equal to what? 50 meter. Then the distance of the object from the foot of the building is 50 meter. Now the second problem. Figure has been given, so it may be very easy, isn't it? Now let us see. A lighthouse AB of height 10 root 3 meter stands vertically on seashore. This is AB. It is a lighthouse. Stand vertically means this is 90 degree. A tower CE and a ship F are standing 30 meter and 10 meter away from the foot of the lighthouse respectively. From here to B to C it is 30 meter. CE is tower. Here F ship, this is 10 meter. Now angle of elevation of the top of the tower from the top of the lighthouse is 30 degree. This is EAD is 30 degree. Now find the height of the tower. We have to find the height of the tower, means CE we have to find, and this one, and also find the distance between the top of the tower lighthouse and the top of the tower. This is top of the lighthouse A, top of the tower E. We have to find, that is AE. Also find the angle of depression formed from the top of the lighthouse to the ship. This A is top of the lighthouse. We have to find this angle of depression, means angle DAF. Now what has been given? AE, AB, not AE, 10 root 3 meter. BC, it is 30 meter. BF, it is 10 meter. To find, we have already collected the things, isn't it? CE means height of the tower. AE means distance between the top of the lighthouse to the top of the tower. Angle DAF means angle of depression from the top of the lighthouse to the ship. Now let us find the distance between, now let us find CE, height of the tower. CE is equal to, observe the figure, CD plus DE. Here CD is equal to AB. Why? They are the opposite sides of the rectangle ABCD. Now AB we know it is, look at the figure, 10 root 3. So CD is also is equal to 10 root 3 meter. Now in the right angle triangle ADE, observe where it is, ADE. Do we know the sides? Yeah, we can find the side AD. AD is equal to BC. Observe the figure. Why? Once again, AD and BC are the opposite sides of the rectangle. So it is also 30 meter. Okay. What is in right angle triangle ADE? We can apply tan ratio, isn't it? Tan 30 is equal to opposite by adjacent. TOA. TOA. Opposite by adjacent. Opposite side is ED. ED by AD. AD we have already understood, it is 30 meter because AD is equal to BC, that is 30 meter. Okay. Now tan 30 is 1 by root 3, that is equal to ED we have to find out, AD is 30. So ED is equal to 30 by root 3. Now let us rationalize the denominator. Root 3 by root 3. Here root 3 into root 3, 3. 3 tens are. So now ED is equal to 10 root 3 meter. Can observe. So the height of the tower CE is equal to how much? 10 root 3 plus 10 root 3. We know it is CD plus ED. CD is also 10 root 3. ED also 10 root 3. So 10 root 3 plus 10 root 3, that is 20 root 3 meter. Now let us find the distance between the top of the lighthouse to the top of the tower, that is AE. How can we find out? We can use the triangle ADE. Okay, in triangle ADE, sin 30 is equal to ED by AE. Here sin 30 is 1 by 2 or half, ED is 10 root 3, AE we have to find. So AE is equal to 2 into 10, that is 20 root 3 meter. So the distance between the top of the lighthouse and the top of the tower AE is 20 root 3 meter. Now we have to find angle DAF. Where is angle DAF? This one. That is the angle of depression. But how can we find angle DAF? It does not belong any of the triangle. But luckily we know alternate angles are always equal. So this angle DAF is equal to AFB, which belongs to the triangle ABF. So now let us write angle DAF is equal to angle AFB. You have to look at the figure and write. Okay. Why? They are alternate angles. Now look at the figure once again. Angle AFB belongs to which triangle? ABF. So now in right angle triangle ABF, tan f, this angle, tan f, tan ratio means TOA, opposite by adjacent. Here opposite side is AB, adjacent side is BF. Tan f is equal to how much? AB by BF. Both of the measures we know. So tan f is equal to AB is 10 root 3, BF is 10. So here 10 and 10 get cancels. So tan f is equal to root 3. For which angle tan ratio will be root 3? We know it is 60 degree. So angle AFB is 60 degree. So angle DAF, this is the important angle that we have to find out, is also 60 degree. So the angle of depression formed from the top of the lighthouse to the, this is the top of the lighthouse, to the ship, this is the ship, is 60 degree. Now let us read the question and understand it well. Two windmills of height 50 meter and 40 root 3 meter are on either side of the field. A person observes the top of the windmills from a point in between them. The angle of elevation was found to be 45 degree and 30 degree. Find the distance between the windmills. Now we are given a field. Let it be AB. Now let us have a diagram. So the first windmill be AC and the second windmill be BD. Now AC and BD are the two windmills. We have to find the distance between them. Means AB we have to find. A person who stands at the point E in between AB, there is a point E, observes the top of the two windmills AC and BD. Here angle of elevation of the windmill AC is found to be 45 degree. So angle AEC is equal to 45 degree. And angle of elevation of the top of the windmill BD is given as 30 degree. So angle BED is equal to 30 degree. And the heights of the windmills are also given. Height of the first windmill, that is AC, is equal to 50 meter. The second windmill, height of the second windmill is 40 root 3. That is BD is equal to 40 root 3 meter. We have to find the distance between the windmill. Means we have to calculate the distance AB. So now we are clear. We are given two windmills and also the heights of the windmills are also given, and angle of elevation from the point E are also given. Now we are to calculate the distance between A and B. Here from the figure we can say that AB is equal to AE plus EB, isn't it? How can we calculate AE? Here AE belongs to the right angle triangle. Which right angle triangle? AEC, isn't it? So now in right angle triangle ACE, tan 45, tan ratio only we have to calculate because this is opposite side, this one is adjacent side. Tan 45 is equal to AC by AE, opposite by adjacent. So here AC is given, opposite side is given. What is it? 50 meter. Tan 45 is equal to 1. That is equal to 50 by AB. Now cross multiply. So AE is equal to 50 meter. This one is 50 meter. Now let us calculate EB. EB belongs to the right angle triangle. Which one? EBD. So now in right angle triangle EBD, tan 30 is equal to, this is opposite side, this is adjacent side. So tan 30 is equal to which one? Now BD by EB. BD is given, tan 30 is equal to 1 by root 3, that is equal to BD, it is given 40 root 3 by EB. So now cross multiply. EB is equal to 40 root 3 into root 3, that is equal to 40 into root 3. 40 into 3, not root 3. Root 3 into root 3, that is equal to how much? 3. 40 into 3 is equal to 120. So EB is equal to 120 meter. So AB is equal to AE plus EB. So AE is 50 meter, EB is 120 meter. So AB is equal to 170 meter. The distance between the windmills is 170 meter. A 1.2 meter tall girl spots a balloon moving with wind in a horizontal line at the height of 88.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. See the figure. Figure has been given. So, okay, it is well and good. Find the distance travelled by the balloon during the interval. Now let us solve. Now what has been given? Figure has been already given, so it is easy to write what has been given and look at the question and then write. Height of the girl. Look at the figure. EF, that is 1.2 meter. Height of the balloon from the ground, GA, it is how much? 88.2 meter. Height of the balloon from the horizontal line. This is the eye of the observer. So EB is the horizontal line. Height of the balloon from the horizontal line, that is BA. How much it has been given? Not given, we have to calculate it. 88.2 minus 1.2, 87 meter. Now CD is equal to opposite sides of not parallelogram, rectangle. Which rectangle? DBAC. Okay. CD also 87 meter. Angle AEB. AEB. That is how much? 30 degree. Angle CEB, this one is 60 degree. To find DB, this one. Now we have to calculate the distance travelled by the balloon, means CA we have to calculate, which is also is equal to DB. Opposite sides of the rectangle DBAC. How can you calculate DB? EB minus this one, EB minus ED. EB belongs to the triangle. Which triangle? Right angle triangle AEB. Observe the triangle in the figure. Then you will understand more clearly. Isn't it? Which theta? Tan theta. because opposite side, this one we know already, we have calculated by adjacent side. Tan 30 is equal to opposite side is BA, adjacent side is EB. So tan 30 is 1 by root 3. AB we have already calculated 87 by EB. So EB is equal to cross multiply 87 root 3 meter. We have to calculate BD. So BD is equal to EB. Just now we have calculated minus ED. How can we calculate EB? To which triangle it belongs? Right angle triangle AED. Observe, not AED, CED. Tan 60 is equal to which one? CD is the opposite side by adjacent side, ED. Here what we have been given? CD, because CD is equal to AB. So root 3 is equal to tan 60 is root 3. Instead of CD we can put 87 by ED. So ED is equal to cross multiply, bring this here, 87 by root 3. So now we have to calculate DB. We have already calculated EB, which is equal to 87 root 3, and ED, which is equal to 87 by root 3. So DB is equal to 87 root 3 minus 87 by root 3. We can take the common thing outside. Which one is common? 87. Root 3 inside the bracket, here 1 by root 3. Root 3 minus 1 by root 3. What it is? Here LCM is root 3. So root 3 into root 3, what it is? 3. 3 minus 1. So that is equal to 87. Here 2. Why it has become root 3 here? Multiply both numerator and denominator by root 3. Root 3 into root 3, that is 3. 2 root 3 in the numerator. Here 3 ones are 3. How much? 29s are. So 29 into 2. What it is? 58 root 3 meter. This is our answer. So dB, the distance travelled by the balloon, is 58 root 3 meter. Oh, this is the question, similar question as the previous one, but here we are not given figure. First let us read the problem. A boy whose eye level is 1.35 meter from the ground spots a balloon moving with the wind in a horizontal line at some height from the ground. Angle of elevation of the balloon from eyes of the boy at an instant is 60 degree as before. In the previous problem also they have told at instant is 60 degree. After 12 seconds, the angle of elevation reduces to 30 degree. If the speed of the wind, here this point is extra. So we have to use distance travelled into time is equal to speed here. Wind is 3 meter per second. Then find the height of the balloon from the ground. Use root 3 is equal to 1.73. Now let us visualize the problem. A boy spotting a balloon whose eye level is 1.35 meter. Spots a balloon from the ground level. But this is the ground level. This is the eye level. at some height from the ground. It is moving with the wind. Speed of the wind is 3 meters per second. At the initial position, angle of elevation is 60 degree. With the wind it moves. Speed of the wind is 3 meters per second. After 12 seconds it moves up to here. So from here to here, what is the distance? Can we calculate? Yes, we can calculate. But above the ground level, its height is same. This is eye level. This is also 1.35 meter. Let this height be h from the eye level. This is also h. This distance can be calculated by using the formula d is equal to speed into time. Here speed is 3 meter per second, time is 12 seconds. So this distance is 36 meter. This distance is also 36 meter. Let this distance be x. Angle of elevation of the final position of the balloon is 30 degree. Now we have to calculate the height of the balloon from the ground, means h plus 1.35. Whole this distance, this height we have to calculate. Let us name the important points. We have to calculate CE. Now we have two triangles, triangle DGB and triangle DFC. Now in triangle DGB or BGD, both are same. This is right angle triangle. Tan 60, this one. Tan theta is opposite side by adjacent side. So tan 60 is equal to h by x. Tan 60 is root 3. Root 3 is equal to h by x. So root 3 h is equal to root 3x. Let this be equation number 1. Another right angle triangle. What is it? CDF. Here tan 30 is equal to h by x plus whole this distance, x plus 36. Tan 30 is 1 by root 3, that is equal to h by x plus 36. Now cross multiply. Root 3h is equal to x plus 36. So h is equal to x plus 36 by root 3. This is equation number 2. Now from equation number 1 and 2, we can understand that LHS and LHS are equal. So RHS should be equal to RHS of the second equation. X root 3 is equal to x plus 36 by root 3. So cross multiply. 3x is equal to x plus 36. Move x to this place. Then 2x is equal to 36. X is equal to 18. This is 18 meter. Putting x is equal to 18 in equation number 1, h is equal to what? 18 root 3 meter. We are given that root 3 is equal to 1.73 meter. Let us substitute. So h is equal to 18 root 3, that is equal to 18 into 1.73, that is equal to 31.14 meter. This is 31.14 meter from the boy's eye level. Balloon's height from the ground, that is EC, is equal to 31.14 plus 1.35, that is equal to 32.49 meters. So balloon's height is 32.49 meters above the ground.